All right, so before we do section 1.5, I want you to go to this page in your notes. We're going to fix a typo. This should be a squared. So go put a little 2 on there and a little 2 on here. This is a super common AP question. It's usually multiple choice. There's usually something missing. We actually just did that one where there was a missing K and you were trying to force it to be continuous. So I want you to circle this word continuous. And understand that visually it means you can't lift your pencil. Mathematically, for piecewise functions, it means that they need to be at the same height. So maybe there's a parabola meeting up with a line right here. Well, if that line goes like that, I don't have continuity. So I have to make sure that the line is at the same height. And maybe then it hooks up with the cubic. Well, I have to make sure that those are at the same height or have the same y value. Otherwise, I will have that jump discontinuity in the graph. So you are trying to force that to happen. So you need to understand what's going on here. You have a parabola going uphill, right? A line that you don't know if it's going up or down because we don't know A or B, and a parabola going downhill. So it's going to look something like this, and then there's going to be a parabola going down, and then there's going to be a line. You need to make sure that the endpoints of the line seal up. So how do you do that? Hopefully you watched the video notes last time. You take that boundary and you plug it in for x, and you just go like this. On the parabola at -1, I will be at the point -1, 1. Agreed? If I were to look at it on a graph, it's the parent function at -1, 1, and everywhere to the left of that I have this. So what I do is I say 1, this height, has to equal the exact same height of the line. So I've got to make sure that my line right here meets up at 1. So what I do is I say, well, when x is -1, make sure you put it in for x. That's what it is. And you might say, well, it's less than or greater than. It doesn't matter. The closed dot, it's already closed. So you're fine with just continuing from there. I would say -1 times a plus b. I have one equation, 2 unknowns. In math, you need to have as many equations as you have unknowns. So if there's 5 unknowns, you need 5 equations to solve it. All right, there's 3 unknowns, you need 3 equations to solve it. Well, what I'm going to do next is go to the next boundary. So I also know that at 1, this guy's at -1, and he opens down. You can see it on my graph. I actually just graphed the known parabola and the known upside down parabola. I'm trying to get the slope and the y-intercept. Honestly, on my crappy, or not a crappy graph, but just my hastily made graph, you can almost see what the line's got to be. Can't you see it? It looks like it's the line y equals what? -x. Yeah, it does. That'll fall out mathematically, though. So even with a very hastily made graph, I can almost see what I need to have that line be. But let's do it with the math, because this is an analytic problem, not a graphing problem. So I also need to go over here at 1 and make sure that at 1, the second 2 are at the same height. So right here, I got to make sure that my line, so I go put in a 1 there, which would be a plus b, is equal to, and I go put in a 1 here, and it would be -1. And then I have 2 equations, 2 unknowns. You do that with the combination method. You should know this from algebra 2, so I'm just going to add them up. I get b is equal to 0. Look at my graph. It looks like the y-intercept should be 0 if I'm connecting those with a line. It really does look like it should, right? So I know that my y-intercept is 0. How do you think I go find the a? How do you always find them when you do these? Go ahead and answer me. How do I find it? Yeah, plug the 0 in for b. Thank you. Go in either equation. I can go plug it in right here. A would have to equal -1. So I can see right here, it says find a and b, that my line that's got to connect them would be -1 x plus 0, or just y equals -x. Usually these are multiple choice, and they will ask you, sometimes they'll say, what's a plus b, and you'd circle -1. Sometimes they'll, have it more what's just the B, but this is a very, very common AP question. Notice it has a star by it. What does that mean? It's on the test. Not this specific one, but this topic will be. So this is one that if you want to be eligible for those test corrections, you would rewrite this one. So again, nothing new yet. Another thing, I never review the easy stuff, but usually I get a very, very common wrong answer for this. What does your gut tell you that is? Just go with your gut. Your gut's wrong, but I want to hear your gut. What does your gut tell you that is, Carson? 0. It's not. So you have to be very careful. Here's why. You've got to make sure that when you do the plug and chug, you have to keep the domain kind of in the back of your mind. As I come in from 5 from the right, like 5.0001, that will approach 0, right? But as I come in from the left, you might say, well, I just plug it in. You got to be very careful about that, because what happens when I plug in a 4.99999, subtract 5? What do I get? Negative, and we can't root negatives, and we don't go complex numbers in here. We're only about what happens in the real number system. So right here, this doesn't exist. So if I come in from the right and I get 0, and I come in from the left and it doesn't exist, guess what the limit is as I approach 5? Which one? It does not exist. Yes, what do you think half the people are going to put on a test for one like that? 0. It happens every year. Even though I have this discussion, it's just so, oh, plug it in and get a 0. That was so easy. It's not. You have to be very careful that you understand that as you come from the right, and you might say, well, that's what we do for polynomials. That's because they have their domain being all real numbers, so you can just plug and chug for all that stuff. But you got to keep that domain in mind, or keep the graph in mind. How can I have a limit approaching 5 when I don't even exist over here? I can come in from the right just fine, but from the left, I don't even have an existing graph. So be careful with that. This I don't think I'm going to review. I feel like you guys have a good sense of the graphical interpretation. So I'm not going to take the time to go through this one, but I will have one like it on the test, where I just give you a graph and I ask you to approach all different things. So you might want to try it on your own, and maybe I'll post the solutions as a study tool, but I think 90% of you would ace this. So do you feel confident in these, reading the graphs? Yeah, no sense. Might as well give you more homework time. All right. I want to go do this one with a star by it. Again, I'm not doing the graphical ones. I'm feeling good about them. So a star means there'll be one like this on your test. Will it be this one? No, right? But there will be one. So we're going to review, and in your notes, the video notes, I said it several times. To show that a function's continuous, it's a 3-part answer. So you've got to be very careful with how you approach it. What's the first thing that has to happen for a function to be continuous at a number? There's a 3-part definition. You might want to go look in your notes and go see, but there's 3 things that have to happen. And when it says show, you need to verify those 3 things to get all the points. They're easy 3, but you have to do all 3, and then you have to answer the question. If you just write yes, you'll get no points out of like 6. All right, if you just answer no, even if no's right, you'll get no points because that's a 50-50 guess. So I need to see you showing. All right, so if you go in your notes, there's 3 things for a function to be continuous. What are they? Number 1, f of c must what? Be defined. Okay, so that's the first thing you're going to do, is you're going to show me that f of c is defined. In this scenario, c is 0. It is defined because of that equals 2 bar. That means there's no open dot there, so you won't be jumping over an open dot. So you're going to say f of 0 equals 1 minus 2 times sine 0 equals, what's sine 0, 1 or 0? Because it matters. So you're going to be 100% sure that you use 0, the y value there. 1. Therefore, f of 0 is defined. Oh, by the way, this is the mathematical notation for therefore. It's universally accepted, so you don't need to write the word if you don't want to. It's like a triangle made out of dots. I don't know if I've told you that before. But what I'm doing right now is saying f of 0 is defined. All right, we've got that. What else has to happen? So I have this closed dot, which is super, but what's the second part of the definition of continuity? Something else has to happen or I've got an issue and somebody's going to tell me. How about you, Charlie? Got it? Yes. Loosely, both sides have to meet up, right? Basically, you're preventing a gap in the graph. All that is super great thinking, but you can't write it. So you have to go to the calculus for that, which is to tell me that the limit, right, as you approach 0 from the left, so we're going to go do that. Let's go see what they are. We have to make sure that as we approach that closed dot, our functions meet up there. So we're going to say, well, the limit, and if it fails this one, you say it's not continuous. If it fails criteria 2, you say it's not continuous. If it makes it all the way through, then we say the function's continuous. So let's go do this. Let's approach 0 from the left of f of x equals. It's going to be this function, which we already did. So I already did it right up there. The limit as x approaches 0 from the right of the function. That means over here, I would have e to the negative 4 times 0, which is e to the 0, which is what? 1, Kenzie, exactly, 1. So are they meeting at the same spot? Definitely. So that's great. So I've got these lines that I've got a defined function at the point. I've also got them lining up at the point. Criteria 3 is just to verify that whatever the location of the solid dot is, it's the same as the limit. So we don't have that open hole with a dropout above or below it. It's very conceptual, isn't it? The math is easy, super easy. Wouldn't you say, Rand? This is easy math. But the concept is kind of higher level thinking. So how do I write my third criteria? I would say the limit as x approached 0 from both sides, right, of the function equaled what? What did it end up equaling? Don't say 1. What do you think I want to write? F of 0. Exactly, honey. Perfect. They were the same. What if this was a 1 and this was a 2? Then for criteria number 3, you would say it did not equal, therefore not continuous. But since all criteria are met, we would say therefore f of x is continuous. Does that mean I'm going to give you this exact same one on a test? No. I will have 2 other functions. It might be approaching a different number. Maybe it won't be continuous because criteria 3 fails or criteria 2. I'm going to tell you I'm not going to have criteria 1 fail because that's too easy. Then there's nothing to do, right? But be prepared. And you have to write it nice. This is what I see for a lot. Kids will go like this, 1, 1. They do it in their head and they write yes. How many points do I give them? None. All right, so be careful how you write it. All right, moving along. Now the new stuff. This is going to go really fast because I discussed it already. I don't always do things in the order of the book. I kind of do them when they feel right. So limits at infinity just mean that when you head somewhere, you end up heading along an asymptote. We've already discussed this a little bit, so we'll have a quick little discussion here before you go to work. We've said that when a function increases or decreases without bound, we say its limit doesn't exist. But I already told you how to refine that, and you did it on your problem set. So there were 3 things that could happen for your answer, and I just wanted you to do it ahead of time. So I said, if it's going up from both directions, like this, you can refine your answer to positive infinity. If it's going down from both directions, you can say negative infinity. Or if it's a one-sided limit and it's just going up, you can say positive infinity. The situation where it truly doesn't exist is when you come in from both sides, and what happens, Sarah? They don't, but one would be going up. Yeah, I can see you doing that. One will be going up and one will be going down, and then I truly have to say it doesn't exist. So most of your answers where you're at an asymptote are going to be positive or negative infinity, unless you're coming in from both directions and you have that one going up and one going down. Keep in mind, infinity is not a number. It is a destination. This causes a lot of heartache for some people because, not heartache, but I mean, people like to say this is 1. You can't use numerical rules with non-numbers. And infinity isn't a number. It's a destination that you can't reach. So this is not equal to 1. You might say, what is it? It depends. It's actually called an indeterminate form because if Mike's heading to infinity and is way farther along than Sarah, that number's top heavy, right? And it's fairly large. But if Sarah is heading to infinity on the bottom way faster than you are, that number is going to approach 0, right? If they're at equal speeds to infinity, then we could maybe say it's 1. But you got to be careful with that. So we've already talked about this. It should be an easy thing to do. Consider this function. It is undefined at x equals 2, and that does not cancel out and create a hole in the graph. So you should be 100% positive of what that graph looks like, right? It's got a what at 2. What does it have? Asymptote, a vertical one. Furthermore, you should recognize its parent function and know that it's been slid 2 to the right, and it's going to be just a little steeper. So really, the graph of it you should be able to do in your head pretty easily too. It has its asymptote moved over here to 2, but it's still got that same parent function shape. It would just actually head up steeper, but that's the general. You shouldn't go to your calculator and need to graph that. So it says, let's see what happens when we approach 2 from the right. And we've talked about this. This would be the limit as x approaches 2 from the right of 3 over x minus 2. Now graphically you can see what's happening because I knew what the function looked like. But what did I tell you to do if you don't have a calculator and you don't quite know what the function looks like? When you plug this in and you get 3 over 0, we said that means a right-sided limit, it's one of these two answers. For sure. Carson, do you remember how I said to decide which it is? Like, I can see it on the graph, so it's kind of silly for me to ask because I can see it's going to infinity. But what if it was a function that you didn't know that and you didn't have a calculator? What could we do to determine which infinity it's going to? Be a creeper. Exactly. Just go be a little creep. Go on here. You don't care what it is. Just get to the right and do a sign analysis. 3 is always positive. The bottom would be positive. So my y's, my functions, would be going to positive infinity. How's that concept for you, Carmen? You good with that? All right. So how about from the left? Well, then I'd creep in at 1.999, doing a sign analysis. I'm going to have a positive over a negative. I could see it on the graph, but I'm talking about what if the function's really ugly, you don't know its parent, right? You don't have a graphing calculator. All you know is you did direct substitution, and unfortunately, you got 7 over 0. That's telling you you're now at a 50-50 guess. It's either infinity or negative infinity, and you creep. And I like the use of your word. What is created when the denominator equals 0 and does not cancel? That's the asymptote. And see, I think you knew this part. I actually taught 1.5 without telling you, so we'll go on here. So it says, evaluate each of the following functions. PS, don't use a calculator if you don't need one. PSSS, you don't need one. Okay, these are the parent functions. You should be pretty comfortable with what their graphs look like. And if you are, it makes it really easy. Ashley, do you remember what the graph of y equals ln x looks like? It was on the last test as one of the 12. It actually doesn't start at 0. It starts, the natural log of 1 is 0. So that's kind of its anchor right there. Why is the natural log of 1 equal to 0, Afnan? Can you tell me that? Yeah, its base is e, so we're doing e to the 0 is 1. So that's its anchor. It's actually one of the weakest growing functions. We talk a lot about strong functions versus weak functions in Calculus 2 and kind of who takes over. Natural log, aside from a constant, has the slowest growth of all our functions. It's really gradual. And it heads down to infinity here. You can't have negatives. You can't raise something to the power and get the negative. So the first question is, what's h of 0? Boom, it doesn't exist, right? It's approaching negative infinity, but h of 0 does not exist. You can't take the natural log of 0. You would be saying e to what power equals 0. That doesn't make sense, right? Next up, as I approach 0 from the left, 0 from the right. Well, as I approach 0 from the left, nothing's there. As I approach 0 from the right, I'm going to negative infinity. Correct? So what do you think my answer is for the limit as I approach 0? Doesn't exist. Yeah, we've got an issue. Now again, I'm going to go to Rachel. Although you might say, I don't know what this looks like, you should, because it's just a small tweak of a parent function. right? It's the 1 over x graph moved 3 to the right. Exactly. Its asymptote's just been sent over to 3. So don't go to your graphing calculator. And again, they don't need to be great graphs. So that's why we did the parent functions. You kind of get my thought process behind what I chose to do in that algebra unit, Alex. All right, so let's go do this. Alex, what would you say for f of 3? I'm going to ask you all 3 of these because you just seem like you want to answer them. Does not exist. Yep, it's sitting on an asymptote, which means it's nowhere. As I approach 3 from the left, Alex. Yes. How about from the right? How about from both sides? Does not exist. All right, let's go down to this one, 1 over x plus 2 quantity squared. All right, this is also a parent function. Its parent function is this guy, right? Do you remember what that guy looked like? Let's suppose you forgot. Do you remember, Rand, what that one looks like? I thought you were nodding. Both sides, yeah, it looks like 1 over x, but x squared can't be positive, so the y's, can't be negative. The y's are always positive, so it will go up like that, and it'll go up steeper than 1 over x, so it's steeper, goes up sooner, and the other side does the same thing. That's 1 over x squared. Well, what does this one do? It moves the asymptote. Did you ever wonder why when it's plus in there, it goes the opposite direction? Like, did that ever bug you when you first learned it, that when it said plus 2, it actually went 2 to the left? It's because it shifts the asymptote over so that my asymptote is actually at -2. It's what's making it 0. So it's shooting up like that and shooting up like that. Are you ready? Dom, so what would I say g of -2 is? You got it. How about as I approach -2 from the left? Thank you. How about -2 from the right? You rock. How about -2 from both directions? Thank you. Is this easy section? Isn't it, Charlie? It's easy. It's easy because we talked about it in advance, but this one I put on here because I said I really want you to know what the graph looks like, and I fear that maybe we forgot what the graph of secant looks like. Can anyone show me what the graph of that looks like from pre-calc? I think you know what cosine and sine look like, probably tangent, right? Because this, do you remember what the secant and cosecant graphs look like? What does it do? No. Can anyone show me? All right, then we're going to take a look. We'll think it through. When in doubt, don't go to your calculator. When in doubt, think it through. So we're going to get to our user-friendly function, 1 over cosine. We're going to determine where the asymptotes are, right? The asymptotes will occur anywhere where cosine equals 0. So anywhere where cosine, which is the x, equals 0. The asymptotes would be at pi halves and negative pi halves. So I've forgotten what the secant graph looks like, right? So I'm anchoring it with its asymptotes. How's that? Are you good with that, the other Kenzie over there? All right, so now let's see. At 0, it'd be 1. But think of what's going to happen. Instead of cosine, it's 1 over cosine. So if the answer was a half for cosine, mine's going to be 2. If it was a fourth, mine's going to be 4. Do you see how it's going to flip way higher? Because so what happens is you get this in here. Do you remember what it looks like? What happens to the right? Do you remember this thing from pre-calc, right, where it makes the U and then the upside down U? So if you can remember the shape, it does that, and then it does this. It's periodic, but if you could just anchor it in. By the way, the cosecant graph looks the same. It's just asymptotes are shifted over. That actually is worth talking about. The cosecant graph would be 1 over sine, and where would its asymptotes be? Can you think of that? What makes sine 0? Give me the 2. Where is sine 0? 0 and pi. So I just have my asymptotes shifted over, but it'll be a similar graph. So now we can go answer the question. What's k of pi halves? It doesn't exist. There's an asymptote there. How about as I approach pi halves from the left? What would you say? Infinity, great. From the right, negative infinity. In general, does not exist. All right. All in favor, raise your hand. We're good with 1-5. It looks good. Feels good. Nearly done. All right. I think we've drilled that into your head well enough. I want to go look at, I think I'll skip that one too. I'm going to go look at this starred one, and we'll go back to that one. I wanted to be done in 30 minutes today. So, yep. All right, I'll make it. So we're going to skip the top one, and we're going to hit this bottom one. All right, this is a review. What would you do with the negative 1/2, Mr. Marty? When I'm approaching negative 1/2, and if this was on your test next Thursday, what would you do with the negative 1/2? You'd plug it in, you'd be grouchy with me for giving you a fraction, but you would do it. You'd do some arithmetic, and I'm going to tell you, you get 0 over 0. Okay? Then what would you do? Factor, yeah, but I chose this one because I'm a little worried about you not having one, that was nice, where the factoring is a little tricky. So I'm going to discuss with you how to help yourself factor. Listen very carefully. Because we know that x equals negative 1/2 is causing the zeros, right? Watch. X plus 1/2 must have been a factor. Wouldn't you agree? Right? Had to be. But we don't like to have fractions in there. So if you just go like this, the 0 of this is negative 1/2. That tells me my hidden issue. I'm going to repeat that. If it was x approaches 3 caused a 0 over 0, I know x minus 3 is on the top and it's on the bottom because I'm plugging in a 3 and I'm getting 0 over 0. When it's a fraction, it's the same thing. The only thing is we don't factor and leave fractions. So you have to come up with, I now know that this guy is in both, and it really makes my factoring less difficult. So now once I figured that out, I know this is going to be 3x what? What's this one going to be? Minus 1, right? And this one's going to be 2x what? Minus 3. And you could check it, but we knew the negative 1/2. I think that's a way quicker way than farting around trying to factor it. You know what I mean? Use the fact that you know who the problem is to create your problematic factor. Now you can cross them off. What do you do from here, Michaela? You'll be my last open. You do. So you got to be careful because it's fractions. So you're going to have a negative 3/2 minus 1. Do you see why I chose this one? I'm a little worried about fractions, but fractions are our friends. Decimals are the devil. So when you plug in a negative 1/2 here, you'll get a negative 1. That's nice. Minus 3 is negative 4. Will you be allowed to leave that? No. You need to clean it up however you want. I think the easiest thing to do is probably just take this 1 and make it minus 2/2, like get a common denominator. Right? I think that's easiest on the top. I wouldn't do the crisscross, go across stuff. That one's pretty straightforward. So you get a negative 5 on the top because you'd subtract over 2 all over negative 4. How did I tell you to combat that all over? Condenses as a product. So what's my answer? 5/8, exactly. Thank you. What does that mean? It means that at x equals negative 1/2, there's a hole in the graph. Where's the hole located? At negative 1/2, 5/8. If I had to plug the hole, what point would I define? I would say f of negative 1/2, you're going to equal 5/8. What do you think, Sarah? Awesome. You guys are listening really well. I wanted to be done in 30 minutes, so I think I'm going to be. Let's go down here. And to repeat one last time. The 3-part definition of continuity. You guys already told me, so it should be fresh in your head. F of C must be defined. There has to be a closed dot there. So if it's piecewise function and you see these guys, it's immediately out because there's no equal to. Okay, so the first thing must be defined. Next, once I have that closed dot, the limit as I approach C from the left of the function, good notation, has to equal the limit as I approach C of the function from the right. What I'm saying is you better arrive at the same spot or you're going to have a jump discontinuity. The third one prevents this guy from happening. I'm defined at C I have a limit at C, but I still have a discontinuity, right? So the last statement is the one that gets people. Megan, can you make the last statement of the day to prevent this from happening and to put this in here? Excellent. Limit as x approaches C of f of x. She used a subject. Has to equal f of C. Awesome and amazing. We are done. Okay? That will be first topic up on Monday. So your assignment, I'll put back up. The one due Monday, this one should go really fast because these limits at continuity, sorry, infinite limits seem to be good for you guys. I'm going to see if I can find where my Schoology is here. Let's go there, and let's go there. So your assignment is the same one that I had up here at the beginning of the hour. Page 85. You can go ahead and start. You should get a healthy dent. It says continuity problem set. If you want to have a light Monday, I'll pass that out and you could do it over the weekend and then just not have a whole lot. A lot of times with you guys are so busy, you like to work on weekends probably more than not. I need to stop this recording. Where is it? No, I need this one. Please let me stop it. I don't want to click there to pause.